Let's delve deeper into implicit differentiation. If you look at this object here, it's really just something that they ask you to do all the time. They'll ask you to find dy dx for something like sine of xy equals 1 minus cosine x. And notice that this isn't easily solved for x or y. So anyway, you find the derivative, and you get dy dx is y prime is equal to this expression here. And what I wanted to do is look at it at a point on the graph. If you look at the graph at the point, move this over, 2 pi, so here's 2 pi right here, this is x equals 2 pi. Notice that you have a slope here going on, different slope for different points. If I allow the point to change, then we will see as p goes up and down along the line 2 pi, I want to find out what the tangent is to that. Okay, so I'll show you the three-dimensional stuff in just a second. I just want to get through this first. So here's your point, 2 pi. If you plug in 2 pi into here, you'll get n over 2 for y. N equals 0, 1, 2, 3. And do the math. Y prime is negative n over 4 pi. And then you use your point slope formula to get the equation of a tangent line to the curve. So when you look at that, then we put the actual tangent line in here, and as we move n, if you notice, let's move in a little closer. Let me do this. There we go, that's better. As we get closer, you'll see that as p moves up and down this graph, you get to the tangent line. And all I did to do this was I put in 2 pi and then n over 2, and then I let n be a parameter. All right. Okay, so there we go. And now I was wondering what would happen if we allowed, instead of it sine of xy equals 1 minus cosine x, what would happen if, let's take off this point, if we allowed that 1 to change. So c changes here, what would happen? So notice this is what's going on with this. And it's like, what's going on is if the 1 changes to c and I allow c to change, notice what's happening here. And it's like, okay, well, how does that happen? Well, if you look at this in 3 dimensions instead of the same scenario here, that right-hand side, the c minus cosine x, is this plane, is this wavy-looking figure here. And as we move it up and down, we get different intersections with sine of xy. So if I show it to you like this, that's what's going on with the other graph over here. As I change c, that's what's happening. So in 3 dimensions, you'll see that it's really just something very simple. It's just moving this up and down and seeing what the intersection is. And then you can still, put in your tangent line, but now you make it a plane, and as n changes, the plane changes like that. So what's happening is it's doing the same thing as before. It's just that tangent line moving up and down like that.